Hello Dr. Pagredna. This is my presentation on how to solve Brexit. I will be looking at in particular how the impact on Brexit will affect the pharmaceutical and medicine industry. According to the House of Commons Business Energy Sector Committee, this sector is one of the most productive industries in the UK, with annual turnover of £41.8 billion. The UK exports £11.9 billion to the EU every year while we import 73% of our medicines from them. This industry affects a great number of people as it has a potential producer and customer base of 446 million people in the EU. That's the industry. Let's look at those daunting headlines from the media about the top companies in the UK. I know, right? Scary. My motivation is simple. Apart from the scary headlines from the media and that this sector could impact potentially everyone, it could actually pose a devastating effect. But we need to explore if this would actually happen and what probability and incentive would this give to the EU regulatory body. Talks about diverging away from the European Medicine Association could cost the UK up to £45,000 for each new medicine released in the UK. So we need to see what the optimal response is to avoid all these scary outcomes. Within my family, my older brother and younger sister are both studying medicine. So really I want to know the numbers behind what they study so I get brownie points on the dinner table discussion. We will present the game as an extensive form game. Textbook titled Game Theory by Roger McCain says a game represented as an extensive form game when it is shown as a tree diagram. So our game will be shown in this form on the next slide. As you can see, the slide highlights the main points that need to be highlighted with extensive form games. Please take a second and observe. This is the game we will be focusing on. The players are the EU regulatory body, which we can take as the European Medicine Association, and the other player is the UK pharmaceutical industry. The actions the EU can take is not to change the regulation, changing the regulation to benefit everyone, meaning not just the EU and UK but also the wider market of the rest of the world, or changing the regulation in order to gain market power after Brexit. The UK's actions are to accept or challenge. The payoffs may seem odd, but with the research from reports and what news article states, those are the likely payoffs each player would get. Take it as the payoffs are in an ordinal preference. Now, because of the assumption of perfect information, solving this game is pretty simple. Take a look. So the EU has three actions that they can take which are highlighted. Now with backward induction, we must look at the last player's move which are being underlined by my trusted tool, the pen. In the cases where the UK industry has a choice of moves, they would pick the greater payoff. With perfect information in mind, EU would pick the action with their payoff given the best possible action the UK industries. With that in mind, they would pick not to change the regulation regarding pharmaceuticals coming in and out the UK. After we scribble under our solution, let's change it up. Let's make it so that the UK industries do not really know if the changes to existing regulation would be to benefit everyone, or whether the EU is doing a power move. The updated game has one very important change, and that is that we have introduced imperfect information. Now backward induction cannot work as we don't know the payoff if the EU regulatory body decides that they will change the regulation. So how do we work it out? Well, we will end up with a mixed Nash equilibrium if they decide to change it. We will focus on the main sub-game which is in the red circle. This slide is just showing the payoff matrix for the main sub-game we have highlighted in the previous slide. As we can see, each player will have a different response depending on the other player's action. We then need to work out the probability to find out the belief and expected payoff. Please refer to Appendix A for full workings. What we have found out is the payoff function so we can work out the expected payoffs. The result is that the EU will take the action change for greed with 75% probability and change to benefit with a 25% probability. The UK industry will choose accept with an 80% probability and challenge with a 20% probability. So why did we do this? And what's the end result? We did this because we wanted to find out if the expected payoff for the EU to enter the sub-game, and deciding to change the regulation was greater than the payoff for not changing the regulation. Appendix B shows the full working and we find that the expected payoff was less than the payoff to not change the regulation. This is the optimal response for both players. In numbers it was 61.25 and 62. What we have shown through an extensive form game is that the players should keep to their existing agreement. It would be detrimental for both parties if the EU decided to change the regulation regarding medicine. They are already so connected and any changes to the regulation of medicine should be taken off the table. We shouldn't have situations like AstraZeneca building factories in the EU as well as the UK to make sure there is not a stop in supply of medicines to the people who need them. We have identified the optimal solution in our game. Thank you for watching.